I'm be a Java champion since some years. And since last year, which is the topic for today, I'm part of the AdoptOpenJDK TSC of the Technical Steering Committee. And yeah, so this is where we want to talk about today. If you have any questions before George introduces himself, you can ask us everything in the chat in German or English if you want, because I will have a look at the chat at the whole session. So just ask questions whenever you want, and yeah, I will have a look at it. Okay, so I hand over to George.
Brilliant. Thanks for the intro, Hendrik. So unfortunately, my credentials are not quite as good as Hendrik's. I'm the Java program manager at Microsoft. It's a reasonably newly set up group in Microsoft. For those that haven't seen, we've been kicking things off with the recent JD Conf, which is super exciting, Microsoft's first ever Java conference. I'm one of the co-founders of AdoptOpenJDK, so it's very close to my heart. I've been working on the project since day one. And also, like Hendrik, I'm the chairman of the Technical Steering Committee. And I also like to play around a few other open source projects. I'm a core collaborator at the Node.js Foundation, as well as being a Foundation Bootstrap team member at the OpenJS Foundation. So I guess let's sort of dive straight into what we're going to be covering today. We're going to do a quick dive into terminology. There's three important terms here that we always try to clarify before we get started because it can be a bit confusing. And then Hendrik's got some really nice slides to demonstrate the OpenJDK workflow for you all. And we're going to look at vendor distribution and the differences between each of the Java vendors out there today. And then because we're biased, we're going to focus on AdoptOpenJDK and talk about the history. We're going to cover the move to the Eclipse Foundation, which hopefully a few of you have seen. And then we're going to talk about the build and test pipeline and what we have in the roadmap going forwards. So without further ado, quickly diving into terminology. So as I say, there's three key terms here that we want to clarify before we start talking. The first one is OpenJDK. Now, this is probably the one that you're all most familiar with. OpenJDK is the open source project which represents the reference implementation of the Java SE standard, the standard edition standard. And so what that means is there are no binaries produced by OpenJDK per se. OpenJDK is just a source code product. We then have an OpenJDK binary, which is whoever went along and built that source code. So we could have the Hendrik binary and the George binary, or the IBM and Oracle binary. And finally, we have an OpenJDK provider in that sort of example. Hendrik would be the provider. It's a vendor who provides the binary. So they build it from the OpenJDK source, and that is where you end up with a provider. So to kick straight in, I think it's on to Hendrik to talk about the different vendors.
Yeah. So when having a look at this list, we see a lot of vendors, or let's say providers that provide OpenJDK based builds, like Java runtimes, let's call it like that. And a lot of those you don't care at all, like maybe 3 years ago or something like that. You just went to Oracle, downloaded your Java 7 JDK or JRE, installed it on your machine, and you're happy. But yeah, things have changed, and today there are a lot of vendors on the market, like Oracle, which is maybe the in this case the most how to call it in English, the oldest vendor. But we have a lot of new vendors, for example, like Amazon Corretto, or like Bellsoft Iberica, some other companies that have become bigger impact, like for example Azul with the Zulu binaries. And you hear about companies like, for example, Red Hat or SAP that already have binaries since some time, but maybe 3 years ago, less people were interested in that since today. So how is this all happening? Why do we have that much vendors, that much different Java binaries where we need to select one from? And where are the difference between all these binaries? So let's have a look at that and at the history. And to do so, it makes sense to have a look at the release train of Java that has changed within the last years. So what we see here is not the OpenJDK release train of the Java or general release train of Java. What we see here is the release train of the Oracle JDK. As we will see later, a lot is in common to other providers and release trains of Java binaries, but here we see especially the one from Oracle. And this has some points we need to have a look at. First of all, what happened or what was announced, like I think it was 2.5 years ago, something like that, is that the Java release train changed from a feature-driven development, which means like, okay, the next version will be released when all the features of the versions are ready, to a time-based release management where it's defined like, okay, we will release the next release on that date, and we don't care if a feature is ready or not, depending on that, it will be in the version or not. And the next big thing is the duration or the life cycle of the versions, because starting with Java 9, we have a new release of Java every 6 months. So we currently, in the period of Java 15 already, and 2 years ago, we were at Java 9 and 10. So this is really moving forward quite fast. But in the future, a Java version like Java 6, 7, 5, and so on had a quite long lifetime for several years, and you were able to download updates of that binaries from, for example, the Oracle Technical Network for free for years. Now the versions have only a lifetime of 6 months. So when having, for example, a look at Java 10 or Java 14, you won't get an update of this release after 6 months. The development of that release totally stops. But next to this, we have some releases like Java 8, Java 11, next will be Java 17, that are defined as so-called long-term releases that provides updates over a much longer period of time. And now we come to a point where I mentioned that this is the Oracle JDK release train, so specifically for that Java binary, because now we have a look at the colors. So we see that the releases here have different colors. First of all, like Java 9, 10, at the beginning of Java 8, those are green, which means they are free. Those releases were released under GPL with ClassPath exception library, and you were able to use them for free in production, in universities, for education, wherever you want to. And you can just download them, or you just downloaded them from the Oracle Technical Network and use them for whatever you want to. But this changed. So at the beginning of 2019, Oracle changed the license of their Oracle JDK to a more commercial license. And starting with Java 11 and Java 8 update 200 something, you are not allowed anymore to use the Oracle JDK for free in production. If you want to use the Oracle JDK in production, you need to pay to Oracle. You need to have a support contract. While you can still download that version, you are not allowed to use it. And things are even getting more complicated for long-term support updates, where from time to time you're not even able to download those. Some of you might heard about the Oracle OpenJDK release, which is when starting this release train, second release that Oracle provides, but this is used totally in free. You can use it without any problem, but this has no LTS support. So here, even Java 11 and Java 17 only stay for half a year. That's a problem. And to understand why this is a problem at all and what we can do here is one critical thing, the workflow in the OpenJDK and how the OpenJDK involves. And to do so, let's have a look at the development workflow of the OpenJDK. So I try to minimize the complexity here as much as possible. So if someone in the audience is working at the OpenJDK, forgive me about that simplification of the OpenJDK workflows. But let's think about the OpenJDK as a repository, a source code repository in general. And in the bottom, we see like the master branch. And in the master branch, we get new features in. Here we have two different kinds of features that you can see in the red and green bubbles. So the green one are new features and the red one are security or other critical security fixes or other critical fixes. And the OpenJDK involves in the master branch new functionalities, new APIs, new language features are added to the OpenJDK. And from time to time, the OpenJDK wants to do a release, like we see in the slide for Java 8. So for Java 8, then a special branch, fork, whatever you want is created and tagged as the Java 8 release. And what now happens to have future security updates and updates of Java 8, all the security fixes that are part of the OpenJDK and that will be done in the master of the OpenJDK will be migrated to the Java 8 branch. And based on this, OpenJDK vendors can provide updates of Java 8 that contains security fixes, like new binaries every 3 months or something like that, that are built out of this fork or branch that you can see here in Java 8, which is quite nice. But there's always a point where the support of such version ends. In the new release train for a lot of versions, this ends after 6 months. And what happens then is that some vendors, like for example, Oracle, IBM, or some others, copy or fork the state of an OpenJDK release of the sources and continue to develop those or maintain those sources in a private repository that is not open source anymore. And this is only for paid customers. So if someone wants to have, for example, today Java 7 support or something like that, you can go to a company. I don't know what companies all provide Java 7 support, but I know Bellsoft, for example, does it. I assume Oracle does it too. This is done in a private repository, and then as we can see on the next slide, what the vendors are doing is they just migrating the security fixes from the OpenJDK into their private repositories, and based on this private repositories, they provide builds that are for the commercial customers that have bought commercial support. And this can end in some problems. Because, so let's first of all think about what a security fix is. So a security fix is normally for all the people in the audience, and I include myself here too, that are not working on the totally freaky C code of hotspot, often have no idea how a security fix looks. And if you have a look at sources of such fix, often you do not understand anything. If you want to see some insights here, there was, I think it was yesterday or 2 days ago, where George and Martin from Microsoft gave at the, what was the name, George, of the conference?
JDConf, Microsoft
JDConf, a keynote about Microsoft's contribution to the OpenJDK. And there they, this contains some source code of the patches that Microsoft did for some specific garbage collection things. And yeah, first of all, you see it and you're saying, okay, I know why I'm not working on the OpenJDK. But anyway, so this is complex code, and this often means that such code cannot be simply merged, like you do it by clicking a button in GitHub or something like that. You really need to manually, maybe even re-implement the code. Let's think about you have long-term support for Java 7, and there's a security fix happening in the OpenJDK that uses lambdas. You have no chance to just automatically merge that into your Java 7 repository. You need to recreate it by hand. And on this slide, we have now 3 companies, for example, that recreate these fixes by hand. And this ends in Java versions that are slightly different. So after having some of those fixes, you can say that, okay, the version A from vendor A is different to version B from vendor B. And maybe those vendors do not only include security fixes, maybe they do some specific fixes for their customers too, because the customer needs a specific feature, a specific new feature that was added to another Java version. Maybe they need a specific parameter when starting the JVM, something like that. So things here change. And this could lead to different Java versions, which is a quite big problem. And next to this, this leads to having free support, open support, and open source Java sources in the OpenJDK for each version only for 6 months, which is kind of horrible. And to be true, this is the state how it was maybe 1.5 years ago or 2 years ago, where in the Java community, a lot of questions appeared, like, will Java still be free? What happens with Java in the future? Because that was internally the state. Happily, I can say that this is not the state anymore, because as we can see on the next slide, there are companies that go a different way. And one company that I want to mention here is Red Hat, because Red Hat committed themselves to be the maintainer of the OpenJDK 8 and OpenJDK 11 branches or versions. And they migrate and port all the security and critical fixes of the OpenJDK into the 8 and 11 branch, and will do it for the next years, and will do it even for 17. And this is great, because now we have this LTS branches even in the OpenJDK as open source. And based on this information, when we have a look at the release train again, we can see that when talking about the OpenJDK release train, George, can you go to the next slide, please? We can see that for the OpenJDK release train, everything is free, because everything is free. We have the sources for Java 8, for Java 11, and we will have it for Java 17 in the OpenJDK with LTS support, with all the fixes done by companies like, for example, Red Hat. There are some other companies too. I know that, for example, Bellsoft migrate all the fixes they do into the Java 11 branch, which is quite nice. So, and based on this, I'm quite happy to say that now we have a solution, even if we still have closed source Java repositories for long-term support, and even based on those, Java versions can just look or behave different against each other. We have a nice slide prepared for that. But to be true, that was I ordered this picture like 2 years ago, when there was no quite good solution in the OpenJDK. I'm happy that this picture today I can use more for fun, because now we have it in the OpenJDK, and since we now have it in the OpenJDK, we can use it to build free LTS versions of Java. And this is exactly what AdoptOpenJDK does, and I think this is now the perfect point to give to you, George, and give us an introduction about AdoptOpenJDK and how Adopt uses these sources in the OpenJDK to provide free Java binaries.
Brilliant. Thanks, Hendrik. So I'm hoping that after that brilliant walkthrough, everyone has a nice, clear understanding, or as best as they can, of the OpenJDK workthrough. I'm still in my head trying to get my own brain around it. It's complicated stuff, but it's important that we know how it works to then understand the evolution of AdoptOpenJDK. So if we go into the history, the project was actually started around 2003 as what was a Java adoption group. And the key goal here was that contributing to OpenJDK was hard. If Hendrik's slide didn't already reiterate that, I will reiterate that for him. It can be challenging. You have to sign contributor agreements. It can take a long time for your patch to be accepted. And then, of course, you can get your patch into tip, and then you've got to work through backporting that all the way down to the version you actually need it in. And so the group was put together to help people get their patches upstream. If we zoom forward to 2016, IBM created this project internally called AdoptOpenJDK. And the key goal behind this was to avoid the pollution of too many JVM vendors out there. Is Hendrik's slide of everyone lined up on the prison chute is a brilliant sort of metaphor for this. There were so many people building JDKs in their own different way. You had the Linux distros, you had Red Hat, you had Microsoft, you had Oracle. They're all building it in their own different way. And what happens is we get slight indifferences between them. And so the goal here was to create a consistent binary across all of the platforms and make it a place that any company could come and play. And so a short while later, IBM donated all of the code into the adoption group. And that really is where the project as we all know it today was started. Quite soon on, another year later, we hit a massive milestone of reaching 1 million downloads, which I think was a true testament to the project's success. And we were very quickly getting lots of sponsors and other people involved. And so going another year forwards, we had 30 million downloads, which is incredible. And the really key number here is we had 23 sponsors, and that is companies and individuals working behind the project to fund it, to ensure that there's enough people to triage test failures, to fix build machines. And so we really started making some progress. And so I guess it was no surprise to most individuals that another year later, if we go to just a few months ago, we announced that AdoptOpenJDK was going to join the Eclipse Foundation, and I'll cover that in a minute. But we're also super excited to announce that as of about a week ago, we hit 200 million downloads, which is just such a huge milestone for us. And we're growing so quickly in terms of popularity now. So as I already mentioned, AdoptOpenJDK announced its intention to move to the Eclipse Foundation. This was primarily driven by the fact that the London Java community, the group that currently legally backs AdoptOpenJDK, is just a user group. It's a non-profit with no legal aid, no real financial aid. And so we kind of outgrew the project. We needed help, and we needed somewhere that really knew how to run a project of our size at scale and continue to evolve. And so we went through all of the possibilities. We looked at all the different foundations. We even looked at creating our own. And we decided in the end that the Eclipse Foundation simply was the best option out there because it's got such a core understanding of the Java ecosystem today. So as Hendrik and myself mentioned, we both sit on the technical steering committee. We always have a bit of a laugh about this because it's actually not really a technical steering committee at all. It's more of a non-technical steering committee where we handle things like t-shirts and budgets for conferences. And so what we decided at this point was we will split this into two different committees. We will have a project management committee at the Eclipse Foundation. And that core goal will be to drive the project technically, to make sure that we have good roadmaps, to make sure that we continue to excel. And then we will have a working group, which companies will be able to join. And that will have its own steering committee. And that's where they will handle the likes of budget. That's where they're by Red Hat. That's where they're by the Red Hat for Hendrik. And all the other monetary requirements that we have today. And so I guess why AdoptOpenJDK? Well, we really are business-ready binaries. I'd like to argue that we are the place to get free binaries by the community. We have no single vendor behind us, which means there is no lock-in. We have a very broad platform coverage, if not the broadest platform coverage. And we'll cover that in a minute. We put our binaries through an enormous number of tests. And Hendrik's got some good slides later on to talk about that. We have a really clear and transparent support policy that anybody can view. And we're backed by some of the most major vendors in the Java community today. And as I mentioned already, we've had over 200 million downloads. And if that isn't a testament to our project, I'm not sure what else would be. Everything we do is in the open. Our technical steering committee is in the open. All of the project is open source. And everything we do happens on GitHub and on Slack. So everything we do happens there. We have a very, very small subset of private repositories for things like infrastructure issues, but we try and keep everything in the public domain so that other people like yourselves can get involved. So if we look at what a typical build and binaries pipeline may look like, we firstly mirror all of the source code from Mercurial, or also we're very grateful for the project Scala that got recently announced. So what that means is that we have our own copy of the source code that gets regularly mirrored down. When we kick off a build, we choose which branch that we're building from. That is typically master, but it's sometimes dev if we have our own set of patches. And the thing I'd like to say at this point is that we have an upstream everything policy. We don't want to be maintaining lots of patches. We'd much rather work with you to get them into the OpenJDK stream. Once that source code is selected, it goes into our build pipeline, which is a Jenkins instance. And then it goes through something like 85 million tests. I think Hendrik will cover that later, before it gets deployed onto our website, our API, or wherever else you may get our binaries from. And the really exciting thing here I'd like to point out is the approved third-party OpenJDK binaries line. This currently represents the Red Hat provided upstream binaries, which are about as vanilla as you can get. They are built from pure code and uploaded as a means of basically having a reference implementation binary. But it's super exciting to be working with Red Hat on this, and we're really glad that they chose AdoptOpenJDK as the home for this. As I've already mentioned, everything we do runs on our Jenkins CI. And we have a kind of breakdown per OpenJDK major version. So as you can see, this is our JDK 8 folder. And inside that, we have a job for every OS architecture combination we have. So that's Linux on ARM, that's AIX, that's Mac OS on Intel, but also the newly announced Mac OS on ARM. And I must admit at this point, I did possibly pick a slide that was very green. Unfortunately, not all of our builds are this good. I wish they were, but because we have places to improve, we're always looking for people to help. Today, we support 2 different VMs, and we support that over a whole host of platforms. So we have things like Windows, Mac OS, Linux, but we also support more unique things like Oracle Spark, Solaris, RISC-V, which is the super exciting open source embedded hardware, as well as IBM mainframes and a host of other software. And we support 2 different VMs. We support the OpenJDK hotspot VM. For those that aren't familiar with that, that is the default VM that comes inside an OpenJDK binary. So if you use Oracle's Java, you'll be using hotspot behind the scenes. But we also support Eclipse OpenJ9, which is IBM's recently open sourced J9 VM, which is super exciting. All of our sources are based on OpenJDK. We don't have, as I say, we don't have a large patch set. We aren't in there to modify GC or patch Shenandoah. That's not what we're aiming to do. And so we only have a very, very small additional set of build steps, like things like Mac OS notarization, which has been a headache for a few of us in the group, and other small bits like that. So without further ado, I'll hand back over to Hendrik, who's going to talk about test. I think you're on mute.
Yeah, I was on mute because I was typing in the chat, answering some questions, and I don't want to disturb you with the clicking of my keyboard, so I muted me. But I'm back now. So, yeah, since we've now seen that in the OpenJDK we have the sources of Java completely open and ready to use, and even up to date, ready for LTS. And at Adopt, we have open source build scripts for Java binaries at GitHub, and we even have open with Jenkins, so everybody can have a look at how we build our Java binaries. It would be quite easy to build Java on your own. right? You just need to check out our binaries and use this binaries. Have a look at the Jenkins, how we call those binaries, and then build Java on your own. To be fair, it's even easier because what we are doing is in one of our GitHub repositories, we're providing a Docker setup that sets you up a Docker image that's internally is building AdoptOpenJDK based on our build script. So you do not even need to install any tools or something like that, like C compiler, stuff like that on your local machine. If you want to, you can just do it in Docker. But you should not do that. Maybe if you want to learn Java, but not to use such binaries that you build on your own in production. Because something can go wrong when building those binaries, right? And when you just build them, you maybe see the problems at one time when it's too late. And what we are doing at Adopt, and why I say that you should use our binaries, for example, is that we have a huge open source test suite, which is one of the main projects next to the Java binaries that are developed in the AdoptOpenJDK community. And this test suite is called Aqua. It's coming from IBM. So IBM contributed this test suite to OpenJDK. And this test suite is used to test OpenJDK builds. So test OpenJDK-based binaries to check if they perform correctly, if they behave correctly, and so on. And how we do this, we will have a look at now. So when starting to think about testing Java and testing the AdoptOpenJDK binaries, you first of all need to have a look at all the different binaries that we have. As George mentioned, we have a lot of different systems where we build binaries on. Like, for example, Windows, Linux, Mac OS. And next to this, we provide hotspot and OpenJ9 JVMs. And for OpenJ9, we even have two different types. We have the regular one and the cheap based builds. This ends in like 58 platforms where we build or combinations of like architecture, operation system, and JVM, where we provide binaries for. And then we not only provide one binary, like for example, Java 8, we provide Java 8, we provide Java 11 LTS versions. We provide the cousin version like Java 15, for example, at the moment. So this slide needs to be updated. The upstream, which is like the current master. And we have some builds for feature branches too. I don't know if we have specific things like for Valhalla or Loom. I know we have some things there. I don't know for 100% which ones. But in general, we have 6 different versions that we build. And then we have like 250,000 tests that we run to test a JVM. So, and this happens whenever we do a release and for our Nighty builds. And yeah, by multiplying those numbers, we end in around 87 million of tests that we execute per release. And as you might think, this can take quite a lot of time. And therefore, our test suite, the Aqua test suite, supports the execution of parallel tests. So as we can see on the next slide, the Aqua test suite, when executing tests, defines different groups for tests. We currently have 6 different groups in Aqua, and when testing a binary, all these groups can be executed in parallel. And next to this, we can execute the tests for the binaries in parallel. So there's a lot of things in parallel that are happening here. The tests are executed in our build pipeline, and the different groups contains specific kinds of tests. So when having a look at the OpenJDK group, for example, this contains the tests that are part of the OpenJDK, which is around 7,000 tests. Then we have the function and system tests that contains functional and system tests that are provided mostly by IBM. Here we have around 50,000 tests. And now we have some quite interesting groups. Let's talk about the external group last. Let's have a look at the perf, the performance group. So this contains benchmarks where we check that our binaries are fast. So we just have several benchmarks that are executed when running the tests after building our binaries to check that the binaries, the code, the internal code, the JVM performs as good and as reactive and as fast as expected. So if one of those benchmark breaks, the Aqua test suite will break the whole test session and the release cannot happen. The JCK is a group that is made for the Java TCK, the Java Test Compatibility Kit. And we already have this group in Aqua at the moment at AdoptOpenJDK. We do not execute this group against our binaries, but we will add this once we are part of Eclipse at Eclipse Adoptium. Okay, as said, the last one we want to talk about is the external group. So this contains a lot of tests, like 125,000 tests, which is quite a high number, but to be true, we have not written all these tests on our own, because here we include a lot of tests of external libraries, frameworks, and tools, like, for example, microprofile TCKs, or another example is the Tomcat or DerbyDB, where we really execute the unit and integration tests of such tools that are part of such tools, of the sources of these tools, against our binaries to see that our binaries behave correctly with such tools, libraries, or frameworks. So let's have a deeper look at that one and how this is working. Here we see an example for DerbyDB. So Derby is one of the tools, I hope you, so Derby, if you don't know it, it's a Java-based database, a database that is written in Java. And what Aqua does here in the test group, in the external test group, it creates a Docker container, or container in general, and then copy the JDK that we want to test into this container or isolated infrastructure, installs some additional build tools, then check out, in this case, for example, the Derby repository, and builds it. And then all tests that are part of the Derby repository will be executing by using the build Derby version that is built based on our Java binary that we want to test, and by executing the tests with our Java binary that we want to test. So we use these tests to check that they still behave correctly with our Java binary. And then we correct all these tests. And yeah, this is what Aqua then at the end does. It corrects all the tests from all different tests in all groups. And then we have like a green or a red result at the end of all. And then we can decide if we can do a release or not. So this is how we test all the binaries that we provide, with over 250,000 tests to really provide performant and enterprise-ready binaries. And again, all this is happening in the open. So you can see at all time which of our builds had problem, where tests failed, where everything is green, and what tests and how many are executed to check our builds. Yeah, this is next to the binaries, the second big project that we have. We have some other small projects at Adoptio where we can have a look at. Yeah, we still have some time, so maybe we have 1 minute at the list of other projects that we have. If you can, yeah, go to the, yeah. So we already talked about some of them, like the Aqua test suite. We have the, George, have you mentioned the Red Hat upstream builds? I was typing in the chat, so yeah, okay, George mentioned them. We have some other things like ICE2Web, which can be used as an open source replacement for Java Web Start. 10 minutes? What do you mean, moderator? We have tools like JITwatch that you can use to have a look at the running JIT process and analyze it. Okay, we have 5 minutes left, okay. We have JLink Online, which is kind of REST endpoint that you can use to, by calling a REST endpoint, automatically build an adopt-based JVM by using JLink that only contains the Java modules that you need. We provide the binaries for JDK mission control. Yeah, this is what on the slide. We have more things like, for example, we have a REST API that you can simply use to automatically download the latest AdoptOpenJDK releases. You can, for example, use this in Docker container to always have the latest and secured binary for you. And next to this, we're still working on things that are on our current roadmap and on our technical roadmap. And I will give over to George, who will give you an introduction on the things we are currently working on.
Thanks, Hendrik. So I'm aware of the time limit we've got here, so I'm gonna sort of jump through these quite quickly. The main thing that we're kind of pushing for quite hard in the project is dynamic infrastructure. We have a huge amount of static hardware running in the cloud today with public IPs that needs to be maintained and patched all the time, and that's like a security vulnerability to us. And so what we mean by dynamic infrastructure, we are trying to move to an approach where we use a cloud provider to spin up a node when we trigger a job. It runs in a Docker environment, and then the build would run traditionally like it did before, but inside a Docker image that then gets destroyed at the end. Now, I always like putting this meme up because it always makes me chuckle about Docker. But because we're running out of time, I'm just going to briefly explain why we would do this. The main reason is parallelization. If we are able to use lots and lots of nodes concurrently, we can test all of our pull requests faster, which is a gain. But also, where tests sometimes take 17 hours, we can break that down into smaller subsets and very quickly turn a 17-hour test suite into a 1-hour test suite. And of course, when you've got 75 or 85 million tests to run for every release, anything like that is a gain. It helps us get the releases out faster. So without further ado, I just want to say a massive thank you to all of our sponsors that we have on the project today. We really cannot cope without this. We need all of the infrastructure and funding that we get. And hopefully we'll continue to create good partnerships as we go forwards into the Eclipse Foundation. Last but not least, we always like to say a massive thank you to the community as well. It's all well and good us having lots of machines and money, but without people, we couldn't actually make anything work. And so last but not least, if anybody has any questions, please don't hesitate to ask us or get in touch with us via any of the methods mentioned here. Hendrik, you're on mute, I believe, but I'll say whilst you're unmuting, thanks everyone for tuning in and listening. I believe we have a Q&A session now, but I can't see my chat. So
yeah, I'm at the chat. So we have one question. That is an interesting one. So with a more conservative Supreme Court majority, how could a verdict against Google and in Oracle's favor influence OpenJDK or the JCP?
Oh, that's a fine one.
So I had a chance to already think a minute about that one. So let me answer first. Yeah, I think the first thing is I'm not a lawyer, but I think the OpenJDK as it is not really influenced from that. This would influence if so there was this Apache Harmony some time ago, like years ago, that stopped once Oracle bought Sun. Then we have the Google thing. So the OpenJDK is a project and people use it to build. And I think this one won't be really affected based on it. But people that use other interfaces or APIs or copy them into their own project, like copying any Apache code, subcode of a project into your own project because you don't need everything. This will be infected a lot by such verdict. That's just what I can say, what I assume, but I'm not a lawyer and I don't think that I'm more into this specific topic as you are.
Good answer. Yeah, I'm with you, Hendrik. I'm not a lawyer, so I'm gonna refrain from talking about that. The question is there much development going on for J9? Yeah, OpenJ9 is very much actively developed today. The Eclipse Foundation owns the source code. It's not just IBM even developing it anymore. There's a whole load of companies that are getting involved. And it's still very much a relevant VM. In certain cloud workloads, it's proven to be more efficient. So I hope that answers that one. I'll take the silence to mean that we've taught you everything already.
Perfect. That's good. Okay.
And just to reiterate, if anybody does have a question later on, please don't hesitate to get in touch with either the Adopt project or either of us. Our credentials are at the bottom of the slide. We'd love to hear from you, even if it's just really negative feedback about the deck. We're always open to improvements. So please don't be afraid to get in touch. And thanks for listening to us.
Or just join our Slack channel, for example.
Yeah.
Or since we are in Germany, join the German Slack channel if you are not already into the German JVM Slack channel, which is like a very big Slack channel for German Java developers, people that work on OpenJDK and just use Java to develop Spring applications, things like that. Then I think we're done here.
Excellent.
So
Thank you everyone for listening.